Look at this code. We have 4 different functions and they all start and end with the same line of logging code. And look here, the exact same timing code. So if you want to change one log message, you have to find and replace it in every single function. It's messy and it's pain to fix. What if I told you that you could write that logging code once and then decorate and wrap any function you want with it using one single magical line? Welcome back to the final episode of our object-oriented programming with Python series. And today, we are jumping into one of the most powerful and sometimes most confusing topics in Python, decorators. First, decorator is a design pattern. That's just a fancy name for a good idea or a good way to solve a common problem. The problem? I need to add extra behavior to a function without changing the function's code. Second, Python loves this idea so much, it has a special clean shortcut for it, the @ symbol, which we call a Python decorator. By the end of this video, you will not only understand what that @ symbol is really doing, but you will be able to write your own decorators from scratch, like a @timer decorator, to see how long your functions take to run. This is super important part of big projects and web frameworks. So let's get this right. Let's start by seeing the problem up close. Imagine we have a couple of functions that do some heavy work. Okay, first we import time module. Now let's make a function def process data. Inside the function, our first extra job is logging print starting data processing. Let's put a comment extra job logging. Our second extra job is timing. Then we have our real job. I'll just fake or simulate it by looping a timer for 0.1 second for the length of the data. Then after the real job, we do our timing again. End_time is assigned to time.time and print the result. And finally, our logging again, print finished data processing, and then we are returning a string, data is processed. Now look, I'm writing the second function upload_report, and what I'm doing the exact same thing. I'm again timing and logging the code, and this is copy pasting and it's bad. Let's run the code for a dummy data and we'll see that it's running and it's working perfectly fine. But our real logic, the for loop and time sleep 1, is buried all under this setup and tear down code. These extra code of logging, timing, checking if the user is logged in are called cross-cutting concern. The problem is, what if your client or architect says that all log message should be uppercase? We now have to change 4 different print statements in 2 different functions. Imagine this in a 10,000 line project. It's a pain. This is what the decorator pattern fixes. Before I can show you the @ symbol, you must understand the single most important idea that makes decorator possible. In Python, functions are first-class citizen. That's it. What does it mean? It just means functions are values, just like numbers, like 5, strings, like hello, or lists. This means you can save a function in a variable, pass a function as an argument to another function, return a function from another function. And this is the key idea that makes decorator possible. Let me show it to you. So over here, I'll create a function say_hello with the parameter name, which is just simply returning a string hello with the name that has been passed as a parameter to the function say_hello. Now I'll write greet assign say_hello. Notice no parenthesis. I'm not calling say_hello. I am making the variable greet point to the say_hello function itself. Now greet is that function and I print greet passing parameter as a Sumantra string is just calling say_hello, and when I run it, it's printing hello Sumantra. Now for the part 2, and this is big one, we can pass a function as an argument. Let's see how this works. So I'll define a function, my main function, and all it does is print a string. This is the main function. Now I'll make a wrapper_function with a func_to_run as an argument. We expect func_to_run is a variable that holds a function. Inside this wrapper, before we run the function, let's print a log with the text log about to run the function. Then we call the function we were given, func_to_run with parenthesis, and after it's done, we print another log finish. Now we use it. We call wrapper function, and what do we pass in? Our other function, my main function, again no parenthesis. Now I'll again run the code, and that's it. This is the entire decorator idea. We just decorated my_main_function by wrapping it inside wrapper_function. We added the behavior logging around our main function without changing my mains function code at all. This is the moment. If you get this, you get decorators. Okay, now let's make this reusable. The last piece of the puzzle is that wrapper function can also return functions. A true decorator is a function that takes a function as an argument, defines a new wrapper function inside itself, and returns that new wrapper function. It's like a box making factory. You give it a function, it builds a new wrapper box around it and gives you back the new box. Okay, now let's build a proper logging decorator. So we define the decorator function logger_decorator with a parameter func. This is our factory, and it takes function func we want to wrap. Inside it, we define a new function called wrapper. This wrapper is what will replace our original function. I'll write a comment that this is the new function that will replace our original function. Inside wrapper, we do our logic. First, we print the log calling function _name _. The dunder name dunder method gives us the function's name, whatever it is. Then the wrapper calls the original function func with parenthesis. Then it prints after log, which is saying the function func has been finished. Finally, the outer function logger decorator returns the wrapper function, again no parenthesis. Now how do we use this factory? There are two ways. The first one is a manual way. For that, let's define a simple function def say_hello, which is just printing a hello string. Now watch this. I'm going to reassign say hello variable to logger decorator with a parameter say hello with no parenthesis. What does logger_decorator return? It returns the wrapper function. So that say_hello variable now points to the wrapper function. And now when we call say_hello and run it, we are actually calling the wrapper function. It works. We have wrapped say hello function in our logic, but that line say_hello is assigned to logger_decorator passing the parameter say_hello is bit ugly. Python's creator agreed, so they gave us a shortcut to do the exact same thing. So the Pythonic way is the @ way. So at this time, we define say_goodbye, which is printing a string goodbye. And right above the function on its own line, I just put @logger decorator. That's it. This symbol is just a shortcut. It tells Python to automatically do what we did manually. It's 100% identical to writing say_goodbye assigned to logger_decorator say goodbye as soon as the function is defined. So when we call say_goodbye and run it, the wrapper function wraps the goodbye function, and it works just like previously. This is what @ means. It's just a shortcut for passing a function onto another function and reassigning the variable. No more magic. Okay, our decorator is still broken. It has two huge problems. Watch this. What if I try to decorate a function that takes an argument? Let's try to decorate a greet_person function which takes name as an argument by writing @logger_decorator just above the definition of the function. Now let's call it with an argument greet_person Sumantra and run it. This has crashed. with type error, wrapper takes 0 positional argument but 1 was given. Why? Because we are calling greet%, which is really our wrapper function, and our wrapper function was defined without any argument or with no argument. See def wrapper empty parenthesis. So we need to fix our factory. Our wrapper needs to pass everything through. It must accept any argument whatever original function has passed. We do this with args and kwargs. Inside def wrapper, in the parameter, we write star args, comma, double star kwargs. This syntax is catch-all. It means scoop up all the positional arguments into tuple called args and all the keywords argument into a dictionary called kwargs. Then there's no change in calling the function name and logging behavior. Important line is calling the function func will also pass args and kwargs. We unpack all those caught arguments and pass them straight through the original function func. Now let's run greet_person function again. And yes, it's working. It's passing the parameter name correctly without crashing. Now let's discuss this problem number 2, which is what if our function returns a value? Let's define a function add that takes 2 parameter a and b as an argument and returns a plus b. Again, we decorate it with @logger decorator. Now we call the add and print the result. Let's comment this greet function method just for now. And now if I run it, the result is none, but it should be 5 plus 3, 8. Why? Because our wrapper function never returns anything. The add a b function ran and returned 8, but the wrapper function just dropped that value on the floor. Now we need to fix this also. Our wrapper is already passing everything through and it's accepting any arguments, but it should also return whatever the original function returned. So for this, when we are calling the original function with all those arguments, whatever the function func returns, we save it in the variable result. Then after we finished our printing log, we finally return its result. So we are passing the result back to the caller. Now let's run the file again, and now we are getting the result 8. Now let's uncomment the logger decorator also and again run it, and perfect. We are able to pass the argument and we are able to return the value. Both are working perfectly fine as expected. This is a truly useful, reusable decorator. Now we can finally solve our original problem from the hook. Let's build a timer decorator using this perfect pattern. So I'll minimize this. For timer, I'll need time module. So I'll import time. Let's clean this. Okay, now we are defining timer_decorator with func passed as a parameter. Just like above, inside timer_decorator, we'll define the wrapper function. Before running the func function, we run the function time and store its value in the start_time variable. Then we run the func function and save its result in the result variable. After that, again, we'll call time function and store its value in the variable end_time. And then we calculate the total time by subtracting end time from start time. Then we print our formatted message, and I'll use .4f to show 4 decimal places. And the most important thing, will return the result. And finally, we'll return the wrapper function. And now let's go back to our original problem code where we define 2 functions, process_data and upload_report. But this time, they are going to be so much clean. Look how clean is process data. We are having only real processing work inside, no logging and no timing, thanks to @timer decorator. Similarly, over here also in upload_report, all the extra junk is gone. Now let's run the file. And you can see that thanks to decorator, we are getting the time to process data function and time to upload report function. This is beautiful. Our functions only contain the code for what they do. All the how to time it logic is separate and reusable and clean. We can even stack the decorators. Let's see. Let's define a function big underscore job, and inside it we'll call a sleep function for 1.5 second, and we'll stack both the decorator one after other. So outer wrapper logger decorator wraps the timer decorators wrapper, which wraps the actual function. It's just like a set of Russian dolls. Let's run it, and perfect. We are calling the log wrapper and the timer wrapper, and it's perfect. Both the decorators are decorating big underscore job function and giving us the result. I have to show you one last problem. Our decorator is 99% perfect, but it has a side effect. Let's go back to our process data function. So if I ask you, what is the name of our process data function? So I'll call the magic method dunder name dunder and print its output, right? We expect it to say process underscore data, right? Let's run it. It's showing wrapper. Why? Because process underscore data is the wrapper function. We have lost our original function's name, its help string or doc string, and all its info. This can break other programs that try to inspect our function. Python, of course, has a decorator to fix this. It's a decorator for your decorator, and it's called functools.wraps. So at the top, we'll import functools, and inside timer decorator, just above the def wrapper function definition, we add @functool.wrap bracket func. This special decorator copies all the important info like name and doc string or doc from original func over to the wrapper function. Now let's add the doc string or help text to process underscore data. We have already printed name. Let's print dunder doc also at the end, and now run it again. And now it's perfect. It's showing us the correct function name and correct doc string. So we have to always use function.wraps when you write decorators. Now we'll have a quick look at the class decorator. This is less common, but the idea is identical. A class decorator is just a function that takes a class as its argument. So I have copy pasted some code over here. So I have defined a function register underscore plugin, and it is taking class as a parameter. Let's pretend we have plugin underscore dictionary defined outside any function. This will act as our plugin database. Inside the register plugin method, we'll add class to the registry, and then we'll print a log with f-string plugin registered as class dot dunder name dunder. And then finally, we'll return the CLS or class. Now we just decorate our classes. So I have two classes defined over here, my cool plugin, which has a run method, which is running the cool plugin, and another plugin, which is also having a run method. So when Python reads this file, it automatically runs register underscore plugin for both classes and adding them to our dictionary. If I run the code, I'll get the output plugin, my cool plugin is registered, and another plugin is registered. And all registered plugins are shown in the dictionary, which is plugin underscore registry. This is exactly how framework like Flask use underscore app.route to register a function as a web page. It's a registry idea and it's super useful. Wow, that was a lot, but you crushed it. Let's recap the core ideas. We repeat extra code like logging and timing, which clutters our real code. Functions are first class values in Python. You can pass them as an argument to other functions. A decorator is a factory function that takes your function, defines a new wrapper function inside, and returns the wrapper to replace your original. The @ symbol is just a clean shortcut for my underscore func equal to decorator parameter my underscore func. It does the exact same thing. A professional decorator uses args and kwargs to accept any number of arguments, return result to pass back a value, and @functools.wraps to save the original function's name and help text. You now understand one of the most fundamental and powerful patterns in all of Python. Congratulations on completing the 7 episodes Object-Oriented Programming with Python Masterclass. In just 7 episodes, you have learned everything from basics like classes, objects, instance attributes, and methods, all the way to powerful concepts like inheritance and polymorphism. You went even deeper with encapsulation, property decorators, class and static methods, composition, abstract classes, magic methods, and decorator pattern. These are the exact concepts used in real-world applications, frameworks, and large-scale software. So you now have a rock-solid object-oriented programming foundation. Thank you for following the entire series. If this helped you, like the videos, share them, and subscribe to the channel. And whenever you need a refresher, the full playlist is always there. This is Sumantra from Sumantra Codes. See you in the next series.